All right. So I will the first to thank the organizer for inviting me and trusting me with this presentation, even though I'm fairly new to the community. So I wasn't sure what to share. So I aimly I thought I will aimly share what it was like as um, someone new to the community to get your hands on Rocq and to try to do your thing and hopefully spark conversations to how to be better as a community to integrate new members. So first, I wanted to share a bit about my background. So I have master engineering. I worked for about 4 years as a compilation engineers. So I knew KML, I knew type theories, and my point is that as an engineer, I was in a still in even though I was not an academic, I was still in a fairly privileged environment to run Coq, and I think most other engineers like don't know about um, functional programming or type theory, and so for them it will probably be even more struggles that it was for me. But yeah, and so you may ask yourself why engineers will want to learn Rocq, and of course, just because it's interesting and nice. But I had a clear objective in mind, which is I had through my work I had to develop an algorithm for red-black trees. I couldn't find anything online, so I ended up making my own, and then I wanted to share it. And for that, I wanted to have automatic proof, something more than just informal proof. And yeah, but I couldn't find any resources. Since then, I found out that it already existed, but still, I think it's relevant. So um, before um, diving more about what resources you can find on the internet, I've made a few assumptions that could be considered strong or not. That's up to discussions. But first one is that the Rocq community want to have more developers coming in. And by that, I meant people who have more industry experience that may don't know functional programming, that don't know time theory, that maybe have done mathematics at the university, maybe not, that discussables, and that thus the online resources that you find are intended in part for them. I mean, that's highly discussables. And something I noticed is that there is a kind of a cultural gap between developers and academics, which is as a developer you want to find things quick, you want to build, you're not afraid to just start hacking right away, even if it doesn't work, and find out how to get something that um, yeah worked, even if it's not beautiful, if it's not really um, from like even if it's not mathematically pure, where as a researcher you need to go more in depth and you have more time to spend in really going down the materials. And why is this important? Because well, so um, my experience is a bit dated because I it's mostly during 2023 and 2024. So of course since then Coq moved to Rocq. The resources have improved a lot. But how are we going with this? So yeah, so as an engineers, um, you're used to learn new technology, and what you expect is just go to a website and start coding. And I can show a few example. Um, so yeah, if you go to Rust, for example, you type on Google, you go to Rust programming language, getting started, and right away you end up on direct instruction or how to install the thing and everything, and how to get a simple project running. Was well, so I dig up the old version of Coq, which is what I experienced then. You see, okay, so learn about Coq, so get tutorials, or maybe documentations. That's loading, I guess. Right, documentations. Okay, so I'm there again. Tutorial and book. And so reference manuals and and okay, call languages. Okay, that's and then you end up in this kind of interfaces, which um it's not the right page. And well, while you expect code, you have a definition of the grammar, which so because of my experience, that's something that I can relatively read, but I think most engineers, more developer have never seen something like that. And so as I mentioned, since the move to Rocq, this has improved. Now when you go to Rocq, you see install, um, which okay, give you information on how to install it, but okay, how okay, so then learn and then reference manual, and you end up on more or less the same thing. Um, so to be completely transparent, I'm being a bit harsh because um, if you go to get started, you get there where you have so installing and a tour of Rocq, where here you have code snippet, which is what you will expect. It's also from learn and downstairs. My point is that, it's should be probably easier to find. And yeah, also to be completely honest, um, there is also a good chunk of books here, but yeah, I do that with the attention span of a developer who just want to go straight to implementation. You generally don't really pay attention to here, and also you don't really know which is which one you should select, which I mean now it's much better. So that's good. Yeah, I think this should be more visible and maybe, but anyway, as per my experiences, uh, well, I end up asking for to colleagues to recommend me some resources. I end up with Software Foundations, which I think is really good. So actually better than a lot of tutorial that I see because you have, content and directly the exercise. I mean, you can have everything in the same interface. So that's the very smooth experience. So I wanted to, um, yeah, give a praise to that. But not talking more about what it is to um, code in to start your project by yourself. I mean, so I completed all the software foundation, which cover well the basics and very simple data structures and functions to prove. Very simple prove, and so when I had to go to my own project, so I my goal again was to prove deletion for red-black trees. So yeah, the reminders. So I assume you all know what a red-black tree is. I won't re-explain it. And the reason I want to do it because I didn't find it anywhere else. So at first, I expect it to be fairly simple because it's not the most basic data structures, but still quite trivial. The algorithm in itself for deletion that well, I have it here, but that's not. And there are properties of my tree being a red-black trees and respecting the binary search tree orderings are not so complicated. And so the theorem in itself seems quite trivial. And plus, I already implemented it in OCaml. I had informal proof written. So you expect it to be fairly easy, but then when I actually got to it, I'm not sure we see it well. But yeah, I ended up with a lot of on the right page. Yeah, some very long nested proof. And some difficulty I had was that, since you have inductive types, you when you unfold one of the definitions, you tend to unfold everything, and you end up with goals that have, I don't know, 10 level of recursions. And so yeah, so after spending a fairly long time trying to prove not directly my algorithm, but the insertion for Okazaki, which is already proven, but this was more of a like real world practice for me. I end up reading Software Foundation 3, which I've already covered proof of the insertions, which give me some hints about, adding some intermediate data structures, which is, so this is the red-black tree. So it's not really a red-black tree, but it's something that it's used as an intermediate state to prove within the invariance to help the proof. And the other thing that it gave me that I got to learn about LTAC and experience a little bit to make it shorter, so that helped a lot. But anyway, that's for the stories. The thing that I learned from that is a few pain points that I found it. So yeah, ideally you don't want to have proof like that, which makes sense. As a software engineer, you also don't want to have very long code, very long functions. So what you will do is generally refactoring and split it in smaller subfunction, which you can do in Coq, of course. I mean, you can separate your theorem in several micro lemmas, and then you can, within your proof, you can call your lemma. So it's kind of work like in abstractions. The problem when you do that is that you lose the context. And so what happened a lot of time is, what happened to me a lot is I was refactoring, then okay, I managed to prove the smaller lemma, but then when I go back to the theorem and I go back to the point that was before, then I miss a lot of hypotheses. So there was a lot of back and forth using invariants, which then, I end up with this kind of invariant that I have to copy paste to all of my sub theorem. So like propagates from the smaller side, like the shortest part of like the smallest subroutines of my algorithms to the main like the whole algorithms. And yeah, another pain point that I have a lot was because ideally I mean I guess I could have proved uh, excuse me here could have proved the algorithms for just a tree which will have integers. But if then I want to, use the generation function of Rocq to get a OCaml code that then is used in a project, ideally I want that to be polymorphic because I want to be able to implement a lookup map of any type. And so then I wasn't sure, like, how do I express that this is a polymorphic type, but um, I mean in Coq, but this type should be a type with as a compare which is you have a ordering on this type and so on, and so all this yeah, and what are the hypotheses that I have on this type that I can then use in my proof. Yeah, another thing that bothered me a lot is, so again, there was a lot of experimentation and not a lot of planning beforehand. And so I had to, you know, change maybe the structures. And and when you do that, then when you run your code against, when you run your proof against because I wasn't using names or anything, um, the first when you introduce your parameters, it will say it's hypothesis one, and then it will rename that because you change something, and so everything starts failing, and then I have to, maybe I have proved 10 subroutine, and I'm doing my final things, and then I realize that maybe it was better to express my data type as a inductive type, or what it was of my property as an inductive type rather than a function or a fixed point. And then all of a sudden, my first theorem break, and so I have to redo all my proof. So yeah, to solve that, I end up doing catch-all tactics. So that's maybe not very clever, but the idea was there was a lot of pattern that reappear in my goals. Um, Maybe that won't be the case with more complex data structures, but then I had identified these patterns in my goals and in my context and simple way to solve them. So I will write these big catch-all things, and then my proof will be as simple as doing maybe a little bit of management and then applying my tactic. And then that's the naming doesn't um, is not a problem anymore. So from my own experience, what I think would have helped, um, which I'm used to find with other technologies, something like a cookbook. Do I have it here? I think it's maybe your camel when you have like concrete example of use case and so I guess probably you won't um, maybe not as relevant for Coq because they're not maybe not as much reusabilities. Um, uh, and yeah, so in this project, I only use a standard library mainly because I didn't know what of the library existed, and so I sometimes struggle with finding the right, you know, um, data type to express my problem and express my algorithms. And yeah, maybe probably a bit more tool to help with refactoring problem. I'm not sure how easy or difficult it would be to implement. And hmm, a bit more the explanation of, you know, when is better to have an inductive type, when is it better to have a fixed point, when is it better to have a definitions, this kind of stuff. And yeah, that's conclude my talk. So thank you for listening to me. And if you have any questions, please feel free.